So the Earth, as you know, is a sphere, and the position on the globe, to give the position on the globe, is divided up into a grid system. So your grid system goes from the equator in the middle, 0, up to north, 90 degrees, down to the south, 90 degrees. So it measures north, south, from the equator, 0 to 90, which is your latitude. So the UK here is between 50 and 60 degrees north of the equator. Longitude is measured from the Greenwich meridian, or the prime meridian, and it runs through Greenwich, and it's measured east and west 180 degrees. So here we can see that the Greenwich meridian actually runs through the Royal Observatory in Greenwich in London, and it meets at the back of the planet at the 180 degrees on the dateline. So the position is given by latitude and longitude. Latitude is measured 0 to 90 degrees north or south of the equator, which we've said, and the longitude is measured 0 to 180 degrees east or west of Greenwich. So now we have a grid system. We can work out our position anywhere in the world, north or south of the equator, on east and west of Greenwich. So if we look at the position here of New Orleans, which is 30 degrees north and 90 degrees west, we can go 30 degrees north of the equator on the line there, and then we'll go 90 degrees west from the Greenwich meridian, and where these two meet will be the position of New Orleans. Nautical charts. The Admiralty publish over 3,500 charts. If you go on the catalogue, you'll see the charts for the area you're looking at, here UK, and it will show you the large scale charts and the detailed charts. They'll also publish Admiralty leisure charts, which are easier to use on a smaller chart table and a lot more cost effective, and it will be a folio for a certain area. They'll also do folios for areas outside which are popular sailing areas, as in here in Greece. When we look at a chart, if we look at the bottom left hand corner, it will show you the edition number and when it was printed. It will also show you where it says Notice to Mariners, the last time the chart was updated. So it's important before you use a chart or buy a chart to check that it is up to date with a Notice to Mariners, and it's the most recent print of that chart. Nautical publications. So these are publications that are useful on a boat at sea. So a logbook, really important to put information in about your time, how far the boat's gone, the speed, the compass course, your position, your location, people on board, and what you're doing and what you're up to. So you've got information on there. This is a booklet that shows you the Admiralty chart 5011, shows you all the symbols and abbreviations that are on the chart. This is the tidal stream atlas, which shows you the direction and speed of the tide, and we'll go through that during the course. Small craft almanac, you can get that for a large area here from Northern Europe, and it will give you loads of information, or you can buy the one for your selected area, which is more cost effective. Pilot books give you additional information. They're great to read, and they'll also have aerial photos and photos from the water showing you the entrance into the harbours. And you can get them for international places. So if you're going on holiday in Greece, the Greek Water Pilot is well worth reading before you go. Local tide tables, which show you the tidal heights for the places you're going to. Handbooks, valuable information in each of these handbooks, worth having on board. So publications that we're going to get, or we have in our course to look at more deeply. We've got the Training Almanac, which will have tide tables, tidal flow, port information details and port light signals. An important page in the almanac will show you an index of where the places are and the pages they are in your almanac. It will have information on distress signals. It will also have abbreviations. So if you don't understand abbreviation in the pilotage notes, you can look it up. And the tide tables, which we'll come on to. Tidal stream atlases, which we'll go through in the tide section. and pilotage notes, and it will give you details of that harbour, how to get in, and any dangers that you might incur going in. So you need to read it before you go into that harbour. You'll get RWA chart 3 and 4, chart 3 and 4, Northern Territories, Southern Peninsula, and RWA chart 3 is a large chart. With our course, we'll be working mainly towards the top of that chart. RWA chart 4 will be insets from RWA chart 3. They're not to be used for navigation because they're fictitious areas. The depths on the charts are measured in meters and the scale is 1 to 100,000. So if we look at the chart 3 in the middle, it gives us a lot more information. It's well worth reading. It shows under depths. Depths are in meters and reduced to chart datum. Chart datum is a very low tide, which is approximately the level of lowest astronomical tide. Occasionally it does go the tide does go below chart datum about twice a year, and when we work out the tides, we add it to the depths that are written on the chart. So the depths are a very low tide on the chart. So if we look here, very low tide, we can see 27 in the white area circled, that's 27 meters. 3 with the 6 beside it is 3.6 meters, and the 6 with the 1 beside it is 6.1 meters. So it shows you the depth. So when we work out the height of the tide, we add the height of the tide to these numbers. So heights are in meters. If it's underlined figures, it's a drying height above chart datum, vertical clearances and heights above highest astronomical tide. So here we have circled on a green area. So on the chart, the yellow is always land, the white and the blue is always water, and the green is sometimes land, sometimes water, depending on how much tide we have. So the depths on the chart are measured from chart datum. So this circle bit here is in the green. It says 0 with a 2, a line underneath the 0 to show it's a drying height. So at this point it dries out to 0.2. So if we came here at chart datum, this piece of land in this creek will be sticking up 0.2 meters. If we had a tidal height of 0.2 meters, it would just be about covered. If we have a tidal height of 1.2 meters, we would have 1 meter of tide there. Here's a lighthouse, and on the chart it says 6 meters height, and it's 6 meters height above mean high water springs, and that's above a high water, and we'll talk about tidal heights a little bit in the tidal section. This is clearance of a bridge. So under this bridge, the clearance is 2.6 meters, and that's 2.6 meters above the highest astronomical tide, the highest the tide will go. So there will always be 2.6 meters clearance on this bridge. So the rest of the time, when it's not highest astronomical tide, there'll be more than the 2.6. So it's a safety factor. So bridges are to the highest astronomical tide. So it's the worst case scenario of the clearance under the bridge, and depth at a very low tide. So there's always going to be more water than it says on the chart, unless it's below chart datum, which is really unusual. I say about twice a year. The positions on the chart are the datums of the chart. We will talk about this later. We need to make sure that our positions or our datum matches up with the datum on our GPS system. It tells you the buoyage, and we've looked at buoys, and it gives you more information here: pipelines, ferries, high-speed craft, traffic separation schemes. Traffic separation schemes is like a motorway of the sea, and we'll talk about that later, but it's shown on the chart with the magenta arrows and the magenta lines for the separation areas between them. Chart 4, as I said before, is the sections from chart 3. So if we look at the section on the bottom of chart 3, we can see Hamilton Sound, and that's what it looks like on chart 3. But if we go to chart 4, it looks like this, and it's a lot more detail. And then if we look at the Almanac, it gives us other detail. So it gives us information about marinas and facilities in there. Chart symbols. When we look at the chart, there's lots of symbols on there. We could look at them on this, the Admiralty symbols and abbreviations 5011. But what do we have? Well, we have the Training Almanac. There's a page in the Training Almanac with the information, the symbols and abbreviations we have. So when we look at it, symbols, we've got dry land, as I said before, is yellow. If it's sometimes water, sometimes land, it's green. And then as we get deeper, the colour on the chart goes from a blue to a lighter blue, then to a white. So if we look at this again, yellow is always land. Green is sometimes land, sometimes water. And as the water gets deeper, it goes from a blue to a white. On the chart, you will see navigational marks, and they'll be in details, and we can look those up in the reference. Rocks and dangers are shown on your chart. So these are rocks. So if it's yellow, it's always above. It's always land. If it's green, sometimes land and sometimes water. If it's just on the surface, it's the cross with the 4 dots on. And here's another diagram showing the rocks, which will be in your almanac. Wrecks are shown here. For top one, it's sticking out the water. The next one down, wreck, depth unknown, considered dangerous to surface navigation. Next one, wreck over which the depth has been obtained by a sounding, so we know there's 4.6 meters there. And the next one, 4.6 meters, and it's been either dived or swept by a wire. Some of the symbols like this with the squiggles on are overfalls and tide rips. The squiggles on the chart is pretty much what it looks like on the water. Or there can be whirlpools, and that's what it looks like on the water. Or eddies, and that's what it looks like on the chart. If there's breakers, it will look like this. Pretty much how it looks like on the water. And the symbols, and we look at the symbols. So anchorage, anchor. The next one will be pilot reporting. Next one is we can't fish. The next one will be a radio reporting point. So if we're over 20 meters and we have to call up at these points to say that we're coming in. The other one, withers. Withers are sticks that stick in the ground in the mud that show us a channel. And the other one is a light with a limit of safety zone around an offshore installation. And there's more symbols there. And all these symbols are in your training almanac. And again. So thanks very much. Plotting your position. How to plot your position on the chart from a GPS position. You will need your dividers. So with your course you should have your one-handed dividers. You squeeze in the top to make it bigger, squeeze in the bottom to make it smaller. If you've got the RWA dividers for the ENS course, you'll just twist in the middle and it will open it and it will close it. You will have a plotter. This is a Breton plotter. An oblong piece of plastic with a big arrow at one end and a rotational disc in the middle with the between 0 and 360 degrees and small arrows in the middle, and we'll talk about this in a minute. So we need to plot a position by latitude and longitude. We'll get our latitude and longitude from our GPS set, and we want to plot that on a chart to see where we are. If we look at RWA chart 3, if you get it out, lay it out and it's full on the table, you'll see in the middle here it says 46 degrees north. That's 46 degrees north of the equator. And at the top here it says 6 degrees west. That's 6 degrees west from the prime meridian or Greenwich meridian. So the question we want is, what chart symbol is at the position 46 degrees 23.35 north and 006 degrees 23.4 minutes west? So we know it's north of 46 degrees and west of 6 degrees. So if we look at our chart, we know it's north of the 46 degrees and we know it's west of the 6 degrees. So we know it's going to be in this part of the chart. So what I suggest you do is fold the chart 3 in half and have a look at the top left hand corner. And when we look at it, we'll see that the scale on the side, the latitude scale, be 46 degrees, 10, 20, and so on. 6 degrees, 10, 20, and so on. So if we look at the top left-hand corner, here we go, top left-hand corner, we can see the charts. We know that everything above here is 46 degrees. So we look at 46 degrees, 23, so we count out from here. So it'll be 20, 21, 22, 23 here, decimal 35. And here it is, 23.2, 0.3, and halfway again, 0.35. Now what I want you to do now is just put a small pencil mark on here. And from your small pencil mark, get your plotter and put your plotter 90 degrees to the side of the chart and draw a line here that's 90 degrees from your small pencil mark. The tip is to stand up and look straight down at the plotter. Spend a bit of time and effort here to make sure that your plotter is 90 degrees. So this line here is 90 degrees the side of the chart. You want to get into the habit of doing this properly, because a lot of mistakes later on is because this line tends to end up wibbly wobbly because we're not careful. We go to the top of the chart, 6 degrees we said was over here, counted across 6 degrees, 22, 23, 0.2, 0.4. Mark off on here, draw a line straight down. And where they meet will be our position. So the position of 46 degrees, 23.35 north and 006 degrees, 23.4 west is the drilling platform Alpha Juliet Delta on the top left-hand corner of your chart. There it is, plotting your position by latitude and longitude. We can also plot our position by distance and bearing. So if we're given a distance and a bearing, we can work out our position. And the question now is, what feature is 7.4 miles at a bearing of 232 degrees from Point Victoria Light? So first of all, we need to find out where Point Victoria Light is. And here it is on the chart. The position of a light on a lighthouse is in the dot in the middle of the star. So here's Point Victoria Light, dot, star. We know it's a light because it's got a little purple or magenta teardrop to it, but the position is right in the middle of the star there. 232. So I'll always say this, we need to take a step back, look at the big view, then go forward and look at the detail. Where is 232? Sometimes it's helpful to draw a compass rose like this. So we've got north, east, south, west. 232 is over here. So we know 232 is going to be somewhere in this direction. So our line at the end needs to be in this direction. This may sound oversimple to you, but it's really easy to put the plotter upside down, put the arrows in the wrong direction, and we can quite happily zoom off in this direction. And I have seen that happen in a Yachtmaster exam. So think of the big picture in your head first, and then when you finish, does that match up with the big picture? If it doesn't, you've probably got the plotter upside down or the arrows in the wrong direction. There we go. Pointing in this direction, what we do first of all is lift up the plotter, have a look at it, put 232 here in this circle, put it on the chart, put the edge of the chart on the lighthouse, and big arrow goes in the direction of 232, little arrow goes to the top of the chart. So put it on, slide your plotter up and down, twist it round until these arrows here match up with either the vertical line on the chart or a horizontal line on the chart. You may need to move it around a little bit. It's sometimes easier to get this middle disc over where the sea is so you can see where the arrows are, and then stand up, look straight down. Make sure your pencil is on the center of the lighthouse, and then draw the line down here. Okay, so we have the disc lining up with the vertical line or the horizontal line, little arrows going to the top of the chart to north, big arrow in the direction you're going. Then we need to measure 7.4 miles. We always measure from the side of the chart. So measuring 7.5 miles at the edge, count 7 and then 0.4 at the end. And then take it with your plotter to the lighthouse, measure 7.4, and that'll be our position. You can either leave the plotter on there or you can draw the line and measure from the line distance. Well, this is just the opposite way round of what we've just done. So we need to work out an angle between 2 points and how far it is. It's easiest explained in an example. So we're going to measure the distance and bearing from Point Victoria Light to the oil rig that we've just looked at. So here we go on the chart, easier to see. Point Victoria Light, it's in the middle of the star, and the oil rig, the position of it is the dot in the middle. So we need to measure the distance and the angle between the two. So it's from the light towards the oil rig. So we'll get our plotter, we lay the edge of the plotter on the lighthouse at Point Victoria Light and on the oil rig. And make sure that it is lined up carefully and correctly. It's easier to stand up and look straight down. It's good to have a sharp pencil, a 2B pencil if you can get hold of it, and draw a line between them and make sure the pencil line goes through the middle of the lighthouse and the middle of the buoy. It's good to get in good practice here, because once we set off with good practice, we'll keep this good practice all the way through our navigation. Make sure the big arrow on the plotter here is pointing in the direction you're going. It says here, direction of bearing, and it tells you on the plotter. And then rotate the middle of the plotter so the small arrows are pointing towards the top. And then align the grid in the middle of your plotter here on the rotating disc so it lines up with the vertical or horizontal lines of the chart. I find it easiest to stand up, look down, and then move the plotter so it's over the sea, so it's easier to see these vertical and horizontal lines, and then make sure you double check that your plotter is between the lighthouse and the buoy, because it does tend to drift. Some people find it easier to put your pencil on the lighthouse and rotate the plotter around, but whatever you do, you want the big arrow in the direction you're going, little arrow pointing towards the top, and these lines accurately lined up with the vertical or horizontal line. When you've done that, when you look at the dial here, it will give you the bearing between the two. So we'll look at the dial, lift it up, look at it in the light, and it will tell you here that it's 232. Now that's 232 degrees true, because everything on the chart is measured in true. To learn about the compass and how we write on the chart, if you go to our compass tutorial, we'll explain that to you. Is this direction logical? So in your mind, draw a picture of a compass. North, east 90, south 180, west 270. Where's 232? 232 is about here. So in your mind, draw a line from the middle out and in this direction. Does this line up with what we've just been doing? Yes, it does. There again, yes, it does line up. We do this to make sure that we haven't put the little arrows at the bottom or the big arrow in the wrong direction, and we're not scooting off in 180 degrees in the wrong direction. So as I said before, look at the big picture, then look at the details. To measure the distance, we use our dividers. So with these dividers, you squeeze the top, make them bigger, squeeze the bottom, make them smaller. Put one end on the lighthouse, one end on the buoy. This is pictorial. You might find it better, and it is better practice, to have your dividers about 20 degrees to the chart. And the reason for that is it doesn't make holes in the chart, and it doesn't make holes in the table you're using for your practice navigation. So measure these across, and we measure from the side of the chart. I'll come back to this picture. When we look at the side of the chart, we see that it's divided up. So this is 46 degrees north, 10 minutes, 11, 12, 13, 14, 15. So between here and here is 5 miles. Each one of these is 1 nautical mile. On your REA chart 3, it's divided up into 1, 2, 3, 4, 5. So each one of these increments is 0.2. So 1 minute of latitude. So each degree, north or south on your latitude, is divided up into 60. One of those 60th is called a minute, and one of those is a nautical mile. So if we travel north or south 60 miles, we've travelled a degree. And then put your dividers on the side of the chart and measure the distance. So here it's on 20, and you count 1, 2, 3, 4, 5, 6, 7, 0.2, 0.4, and it gives us 7.4 miles. So that is bearing and distance. Keep going backwards and forwards and having a look at it.